This will be another examples of trapezoidal rule. So, okay, this question is saying that by using trapezoidal rule with 4 strips, estimate the value of this integral, right? So, okay, then here we have using the 4 strips. Okay, 4 strip here means 4 strip of trapezium. Okay, or just simple is equivalent to 4 interval. Alright, 4 equally sub interval. So means that you have 1, 2, 3, 4, 5 ordinates. Alright, 4 strips. So means that from 0 to pi over 2, you have 1, 2, 3, 4. 4 strip, or we said 4 sub interval, or it's the same as 5 ordinates. Okay, that's very simple. So, okay, for now I have to find the h, right? The h, and this is your A and this is your B. So we have to find the h value. The h value is the length of each strip. So how to finding this? So the formula will be h equals to, actually it's very simple, you're just taking pi over 2 minus with zeros, then you know the length of this, right? And you divide the length into 4 equal part, which is pi over 8, right? You are getting pi over 8. So, and this will be your h, right? Your h value will be pi over 8. Okay, for now, we're going to construct a table for this. So we need to construct a table so that, okay, before that we have to know all the x value here, right? As you know that 0 plus pi over 8, so you have pi over 8, and this, if you plus with 1 over 8, you have 2 pi over 8. If you plus with 1 over 8, you have 3 pi over 8. If you plus with 1 over 8, you have 4 pi over 8, right? 4 pi over 8, after simplify, is pi over 2, right? Just like this. If you simplify, you are getting pi over 4, right? So I'm going to put all the value into the table. So this is the table recommended by me. So we have value of x1, which is 0, 0 followed by pi over 8, right? Pi over 8, and pi over 4, which is 2 pi over 8, 3 pi over 8, and pi over 2. So we have we have 5 ordinates here, right? 5 ordinates here, but actually they have 4 strip and 4 interval, right? So now we're going to find all the value here. This is your xi, and your yi will be square root of sine xi. So we have to, as we know that the y1 and the y1, x1, x2, x3, x4, x5, the y5 have to fill in here with no value here, right? And here you have your y2, your y3, and y4. So then this is the total, right? How to get all this value? As I show you in the previous video, we have using calculator. So again, I'm going to show you. Right? Okay, let's see how to using calculator. Okay. So when you evaluate an integral, for either you're doing approximations or you're using integration technique of integrations. So or as long as you integrate a trigonometric function, you have to make sure your calculator angle units or the mode of the angle have to be radian. Like for this is have degree, right? You have degree. So I just changing it, shift menu, so choosing the angle unit and convert it to radian unit. So 2. So we have radian, right? Okay, then only I continue with finding all the values here. So this is a very important precaution step. So now I'm going to key in menu, choosing 9, then fx. Your fx is also y, which is square root of sine alphabet x, right? Sine x, square root of sine x. So pressing equals, then pressing equal again. So we have start, end, and step, right? So as we revise, this will be your start, right? The value start, and this will be end, and the length and the value of h here will be pi over 8, right? H will be pi over 8, the length of each interval. So it's pi over 8 is a bit of a step. So we key in all the value, 0. So start is 0. Okay, then pressing equal, go for n is pi over 2, shift pi over 2. Alright, and go for pressing equals, then go for shift pi over 8, right? Your step. So then you're pressing equal. Of course, they will convert your x value to a decimal value, but it's actually the same. For example, 0.3926 is the same as pi over 8, right? Doesn't matter. This is not important here. What important is the value of y here. So the first value will be 0, right? Because when you substitute 0, sine 0 is 0. So square of 0 is getting 0. And the second value, okay, the first and the last value we're putting here. And for this, the middle value we're putting here. So let's go down. Okay, this question requests for 3 significant figure. 3 significant figures. So in the table we can give 4 significant or 5 significant figures, right? So I give 5 significant figures. So okay, I'm moving down. So I can see it's 0.61861. 0.61861, right? 61861, 5 significant figure, and followed by y3, 0.84, 0.84090. Because as you round off to 5 significant figure, right? So you round off, you're getting this one to be 9, right? 84090. So followed by y4, 96119, right? 96119, 0.96119, and the end value, the value here, the final value I will putting here. So okay, going down again, I will getting 1, because sine pi over 2, sine 90 is 1, so square root of 1, you're getting 1, right? So then I have to total up this value and total up this value and writing here. Alright, we have done with total up the value 1 and total up these 3 values, you have 2.4207. Alright, let's see how to evaluate the integral by using trapezoidal rule with this table. Alright, okay, we have already filling up the tables by all these value, right? So now the last, we have to use trapezoidal rule. As you know that the trapezoidal rule is derived to be a to b fx dx, which can be approximate by the formula of 1 over 2h of y1 plus with yn, which is the first value plus with the n value, followed by 2 times for sum of all the intermediate value, right? y4 up to yn minus 1. Right? Okay, this is the formula, right? So now we're going to use this formula. So integrate from 0 to pi over 2 square root of sine x dx is the same as 1 over 2h. H, you know the value of h here is pi over 8, right? Pi over 8 y1 plus yn is the first value and the sum of the first value and the n value, which is the first and the n value, which is 1, right? Which is 1. So plus with 2 times the sum of the intermediate value, okay? The sum of all this value, which is already here, right? 2.4207. So you must make sure this is correct and we can evaluate this. Alright, okay, this will be the approximate value for this integral, alright, 1.15. So if you're using calculator to get the exact value, as you key in into calculator for this, right, you are getting 1.20 in 3 significant figure. So just now I have give you an extra 2. Actually, we just need to give extra 3 decimal places here to make it become 5 significant figure, right? So we just give 4 decimal, but doesn't matter as long you give more decimal places, it will be accurate, right? As long you give more than extra 1 significant figure, maybe 4 significant figure in your table, or 5 significant figure, or 6 significant figures in the table is okay. All right, so okay, let's look at the exact value. Here is 1.2 and this is 1.15, right? So means that this is underestimate, means that it's less than the actual value, the approximate value less than the actual value. Doesn't matter because we know this is an approximation, right? So how to increase the accuracy such that 1.15 will be approached to 1.19? Very simple. You just increase the number of strips or number of interval. If you keep 5 strips, the value will be nearer. If you keep for 10 strips, you start with 10 strips, means more value, then you will get more near to the exact value. Okay, that's the key to for the accuracy here. But since the question asking for 4 strips, so we're doing in 4 strips. Okay, that's all for this question.